Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi class, welcome back to SIC1004 Physical Chemistry Lab. Now we're going to talk on experiment 4, which is the determination of rate constant of a dissociative reaction. And we're looking at the 4-methyl-4-hydroxy-2-pentanone, also known as 4-MHP. So this is a diacetone alcohol. So we want to find the rate constant for this compound. So this is the video to show the experimental setup and how the experiment is conducted. Okay, so do watch that before you continue with the rest of these slides. So in the presence of hydroxyl ions, the 4-MHP will undergo dissociation to form acetone. And because this is a multi-step reaction, so the overall rate of reaction will then depend on the step which is the slowest, and that's known as the rate determining step. So here we have the MHP undergo dissociation. So they go through this process, go through various steps, and this the reaction step B. In step B, this is a fast reaction. So then it boils down to whether it is actually step C or D, which is going to be the rate determining step. So in terms of conducting the experiment, you are going to use, in this experiment, a dilatometer is used. So a dilatometer here, it's really a unique shape here. It's used to measure the rate of change of volume for the reaction involved. So it has two open ends, one where you fill in the solution, and the other end is where you have the capillary tube, so you can monitor the volume of the solution via the capillary reaction. Now this special this is actually made by our glass blower, so this is really it's scientific, it's also a work of art. Okay, and so you will monitor the change of volume. Okay, there are two tests here. So the source of the hydroxyl will be from the NaOH. Okay, so you will actually submerge this dilatometer in a water bath, and only the bulb will actually be immersed. So this is a wet experiment. Okay, and then you add in the NaOH in the conical flask, and after 15 minutes you add acetone followed by the MHP, and then the whole thing is poured into the funnel, into the dilatometer. And so you want to fill up first, so you open up the tap, but as soon as it has already filled in to the bulb, so you close, and then you will watch it rise, the volume rise via capillary reaction. Okay, and so you're going to do two experiments. Use one that adds acetone and one without. So because you're going to use the same experiment for both, so it is wise to actually do the one without acetone first. So actually this one should be reversed. Without acetone should be test 1, and test 2 should be with acetone, so that you don't contaminate the bulb, the dilatometer. So you do that without first. Okay, so you will do it, you will monitor the reading for 10 minutes, and after that you rest for 10 minutes and then continue with the rest for another 10 minutes. So this is a relatively simple experiment. So the idea is to check whether the addition of acetone is going to affect the rate of the rate of this reaction, this dissociative constant. Okay, so you have here, okay, you want to know whether that this is going to actually the acetone is going to have an effect. So as I said here in the data sheet, we will in class, we will ask the students to actually do the one without first and then with. Okay, and it happened that when students actually didn't cross this out, so they may get the information confused. All right, so these are the data. This is the data by the data by the students, pair of students. So this is the one without acetone. So you have here the values that's needed. Okay, so your concern is only with this one, you have this, the log here and the time. So what you need to do is just plot this against time and use this equation to actually find the associative constant. Okay, so remember from the plot you can actually get those values. Okay, and so this is like this is a straight line, so obviously that this is minus k over 2.303, that's the slope, and that's where you can actually get, and from the equation of the plot you can directly find the value of k. So similarly, you have the data for the reaction with acetone, and so you're going to plot this against time and use that to actually use this equation to find the value of k, and then you just make comparison and just discuss on the results on the plots that you have. And it's best to actually plot it. You can plot it that both plots on one side, and that's that will be better so that you can see much clearly, so you can make a better comparison. Okay, right, so in terms of the contents, the report contents, everything is the same as before. So you have the cover page, the objective, introduction with theoretical background, and compare the results of the values and make your conclusion. So again, references used, and this is also due next week. Okay, all right, so that's it. All right, so all the best and stay safe. Assalamualaikum warahmatullahi wabarakatuh.